Oh,
What is that?
we've not had that before.
Yeah. So how, like, how, I don't know, what is the difference? Because when Lindsay was leading, we haven't heard that sounds at all.
I don't know either. It's
Oh,
just
she has she's magic hands, I guess.
I wonder if it's got a, there's so many settings on Zoom on the online thing that you can mess around with. Everybody has different default settings, and each organization has different default settings. So it's probably just a default setting that lets everyone know that's being recorded.
You're aware.
Yeah, so the recording button is actually flashing for me. Usually it's just solid.
I don't know. Anyway. So I know there's probably been a lot of stuff that's happened over the last 2 weeks, especially with the Transform meeting. So if anyone would like to go first before I call out some names here, that'd be great. I know there's a lot of stuff with talked to individual people about hacking and things. So Tom, you're up in the top left here.
There you go. You named. Yeah, so Transform went well. I'm pretty stoked that I actually spent the time working with GeoSci. It was my real first stab at it. Dieter will talk more about the general, theme what was talked about. But on my end, my goal was to be able to hook up GeoSci to be able to move surfaces in GeoSci, and then get the response right away using SimPEG. Do a forward calculation on the fly. And that's amazing, because I've been dreaming of doing this for years, right? To just be able to move surfaces, do faulting, and then do right away see the response, so that people can do real 3D geological / geophysics modeling. So that's pretty much proof of concept has been done then. So I'm pretty stoked. Other than that, this morning I went back to the discourse. And I realized that I should have answered questions almost a month ago. So I answered a bunch of discourse. And yeah, that's all I have in mind right now.
Don, are you planning to invert that as well? Because I think that's their goal, right? Their main goal of GeoSci actually inverting it, right? That's what I thought. So they actually have all these derivatives, and I think they're using PyMC to invert that. That was my guess.
Okay, I haven't started to look into it. I know that they have an inversion module that is not really documented right now. I think because I can spend all this time because the company is interested in bringing this in, but it's probably going to be towards more BPMG, because BPMG needs an easy surface modeler.
Right.
So I'm guessing that my next iterations on this will be to just for a model, and be able to feed in a surface model to Analyst or GoCAD or something, so that that people can work with BPMG. Yeah, cool. But that would be interesting for sure. Yeah, good inverts, right?
What do you mean with inversion, Sogi, when you talk about GeoSci?
So let's say you got 3 layers and 1 fault. So you can parameterize that with 10 parameters, I guess. I don't know, but you have if you but it's still pretty uncertain. You have very sparse data set from 10 wells. So they're large uncertainty, I guess. But if you got your physical data and then try to fit both your hard data as well as your geophysical data, then that's sort of integrating all the information. I thought that's where they're going.
Yeah, they do a lot of stochastics, and I think at the moment they still have Theano as their main driver, but they try to move to PyTorch because Theano is not maintained.
Theano is gone.
Yeah.
So.
Because I don't think it would be too hard, right? Because the way they generate their kriging for the credit surfaces and that is basically a few points, and then they have some fancy ways to generate weights everywhere in a 3D grid. And so if you could just move basically code the inversion to just move a few points that can warp the entire space, then That would be
like when I was talking to him, I think one of the main developer, he said that inverse problem is so nonlinear. So just doing a gradient-based approach didn't really work. So he said, oh, he had to use the stochastic approach, like a Monte Carlo market chain. But yeah, I wasn't sure because I haven't tried.
Yeah, and you know, a lot of people try to do inversion and they don't have the experience that we do. I think if we prime it, it would probably be possible.
Yeah. My feeling, like the current trend is like stochastic inversion, but people haven't really tried much with gradient based because it's hard. Like the balancing is so hard, and so if you're like sort of not doing well with the balance,
then you give up. You give up right away.
Right? Oh, it's not working, but that's not quite true because you haven't pushed hard. Anyway.
I think the same.
It could be fun to sort of look into what kind of things we could potentially do, you know, starting with like an L2 inversion or a sparse inversion, and then trying to then like extract sort of a first estimate of surfaces and things like that from that. Is, you know, because I mean, if we're doing these more parametric inversions, like starting at least in the right ballpark is so important. So yeah, there's some cool things that we could do in there. That's really exciting, Dom.
I've also been interested in trying to combine it with like sort of a machine learning type approach to generate a bunch of training sets.
Right.
Yeah, that's a good idea. There's also a good point of connection there that I haven't had time to explore, but is that currently like the default base mesh that they're using to do all the kriging is just a tensor mesh, which obviously gets really heavy if you try to do large models. And that's where Discretize could fit in perfectly, because it also, like GeoSci also allows for like just a scatter points to do the kriging. So we could use the octree mesh of Discretize to feed into GeoSci just to speed up the their calculations.
Are they using kriging just for 2D surfaces? Is that
no, in 3D? Yeah, 3D. That's how they figure out, right, which is lithology 1, 2, 3, the defaults and everything, right? There's basically like a kind of a kriging interpolation that's happening in the background, and then they figure out what's the best position of their interface, and then they draw surfaces from that.
Right. So that's like that's still like a 2D surface, right? Like that's how.
It's a 3D volume of values, and then they draw surfaces through it. If I understand it well, Dieter, correct me if I'm wrong here. But.
Okay.
Yeah, I think it's inherently 3D, but there are 2D surfaces they are dealing with. So folds and layers, and the idea is that you basically can then pull out any point you want, and it gives you the layer it is in.
Right. The reason why I ask is a lot of geostatistical algorithm is actually used uniform, like it's still a tensor mesh, but the cell size not varying. So, because that allows them to do very fast computation, like using Fourier transform and that types of stuff. So.
I've asked Miguel, and he said if it's unstructured, there should be no extra cost in terms of computation. But I guess we'll have to try.
I think that's because 2D kriging. So once you move 3D, it's very expensive. It's not cheap. So
I don't know how many extra things it does, because I don't know if someone saw the master students that work on at the moment, where they try to find out the distance from point A to B, taking into account stratigraphy. So it will assume where it has been like the faults and unconformities and faults and all these things. So yeah, I think there goes a lot inside, and I'm not entirely sure how this is done.
Oh, okay. Interesting.
It has a lot of nifty things, I think, yeah.
Cool.
Well, Dieter, then you want to continue and tell us a little bit more about what you were doing up to then?
Yes, I can. I definitely did a lot less work last week for my work than I thought.
Yeah.
Yeah, I think it was exciting, this whole hackathon. I was originally only involved with Filippo to co-host some live hack meetings. So he's not alone. He looked for co-hosts for the catch-up meetings. And then it was like a week before the hackathon. I said, "Dieter, where is your project?" And I said, I don't know. But there were almost no projects. It was kind of, because it wasn't a physical hackathon, people didn't seem to be that committed originally before it actually started. So then I just put in this project. I thought, well, anybody that is not interested in seismic could come on. And basically what I did a year ago with going from GeoSci to discretize to SimPEG or to my code, thought we could do some examples. But then in the end, we were about more than 50 people in the channel, and about 10 very active, which was Dom and Miguel and Richard from Australia and a couple of others, Andrew, Martin from Africa. There was really a lot of examples sampled from Fatiando to GeoSci, from Petrel to GeoSci. Richard did some mineral composition chemical to GeoSci, Dom, SimPEG. So all these examples happened, which was quite exciting. And then it was mainly Dom actually and Miguel who pushed, and Bain actually as well, who were more interested in pushing this subsurface package, that we have something that can talk between different communities, which should be as minimal as possible, but accepted by others. And then cool. Franklin chipped in once with the OMF format, open-minded format, and Rowan chipped in. And I think it was Rowan then who said that it doesn't matter how good it is at the beginning, but it's important that we as communities commit to it, that we're going to use it and support it. And then in the end, there were like 6-7 communities that said, yeah, we're going to do that. So yeah, I think I'm excited about what's going to happen with the subsurface and where we go within a couple of months' time.
And Dieter, how sort of, oh, sorry, I was just going to ask how the conversation sort of with OMF, how did that kind of evolve? Are there pieces that we'll take, or is it sort of like a reference or a bit of a different trajectory?
I don't think, well, maybe Dom chips in. I don't think, as Franklin said, it's definitely not dead, even though it was a bit dormant maybe. They're very willing to include, I think, changes. And as he said, it's a very small project, few developers, so, and he's one of them, so there would be a high chance to get things in. But I also thought that we agreed that subsurface shouldn't, OMF should be one format and maybe GeoSci.xyz another one, how you actually store it on disk, and subsurface should more deal about how you store it in memory and how you exchange it between tool A and tool B. So then I think that would be, yeah, a good approach to have at least OMF. And then Andrew said this Open Geospatial Consortium, which also seems to be an interesting thing, which is yet another format. Yeah.
But that one was 2D, right? I think people were kind of shriveling at the idea of trying to do 3D with it, but yeah.
Yes, but as a backend, it could still work. Then if you only have horizons, for instance, then yeah, why not? Why then still subsurface should be able to put out a pure 2D format if the only data you want to exchange is 2D, right? Something like this. But yeah, I mean, it's very early stage, but then Bain and Miguel, they already put in a lot of structure. And I think Bain has a lot of experience and has a lot of, as he said, errors he made with PyVista that he doesn't want to make now with subsurface. So improve on his learnings, which is already very promising. Yeah.
Is there like a GitHub or like some sort of like
yes,
web?
On GitHub.
I put it in the chat.
Subsurface.
I put it in the chat. So.
Also got it in the notes as well.
And then maybe the summary page of the, I can put that one in. Yeah.
Cool.
Yeah, I think that's most that I have to tell from the last 2 weeks. Plus the fun being in the backstage of Lindsay, this VIP feeling of that almost everybody was up there anyway, but it was kind of fun. How was it for you, Lindsay? This 3 hours marathon?
It's really strange. I mean, it was a lot of fun, and once you sort of get into the rhythm, it was okay. But it was really weird not having like any visual feedback, because in a classroom, you sort of feel like, you know, you can pause when you see people thinking. But this, I felt like I just needed to fill like 3 hours with like voice, and so I definitely had like no voice after that.
It kind of reminded me of, I'm not sure if you guys have ever watched anything on Twitch, like people streaming video games. Essentially, they essentially stream themselves playing video games, but they're talking to people in the chat that are responding to them, and they're responding to the people in the chat as well as what's going on.
Right.
So it just kind of reminded me of that kind of format, and it just, I wasn't sure how much of a delay there was though, which I think that it seemed like there was a decent delay when you were typing to us and you're like, oh, how does this work? And then like 15 seconds later, you did what you asked how it worked.
Oh, strange. Okay.
There's like a decent delay, which was kind of odd.
That's a YouTube delay. They warned it would happen.
Yeah.
I also thought that was a security delay for any Zoom issues.
Yeah. So there was a delay between like when I spoke and when it went to YouTube. But then it's possible that there's also a delay, like between audio and video periodically. Yeah, but thanks everyone for being on Slack and for answering questions, and that made like such a huge difference, and surfacing interesting questions and things like that. It was really cool to see that there was so much motion happening, and just like that was also really motivating, is just knowing that like people were paying attention.
Right.
So I should keep going. So I really, really appreciate that. And it seems like we got a few more people that jumped into Slack, and there's more interest. I think Peter's pretty interested, which is really cool. I got a nice email from him thanking me for the tutorial. So thanks, Joel.
I saw him jump on the Slack channel.
Yeah. So that's pretty cool.
Talking about Slack channel, there was this question there in the tutorial from a Chinese. If somebody could look at that, he then wrote me in a PM because I was the only one responding him because you were all asleep. And I think he was very excited. He said, like, first time I speak to someone outside of China and I don't know how to use SimPEG. That yeah, I'm not actually understanding what you're asking, but I'm sure the SimPEG folks will answer you in the morning. Something about how to create meshes or so. I'm not exactly sure.
Sorry to interrupt. John, are you to that meeting in 8 minutes?
No.
Diaz Cloud Computing? No, you're not.
That's actually news to me. I didn't see any email about that.
All right.
Yeah, that was it. Must be Jonathan. Yeah.
Okay, sounds good.
To do.
So I'll have to turn off. But I'll see you next week, guys. I'll see you online.
Right on.
Bye.
Right.
Okay. Well, Sagi, what have you been up to?
Nothing really particular. Yeah, last week was kind of weird. I wasn't actually sure what I was doing. Yeah.
Okay.
Yeah. Well, what I'm working on in these days is sort of the final part of this California project. It's a 2-year project.
Mm-hmm.
It's coming to end this October. So we're sort of, getting to an end. And the last part kind of incorporating like all uncertainties happened in all the steps. So I was playing with some geostatistical algorithm that could potentially encapsulate some of the uncertainty from geophysics as well as from other logging data and that types of stuff. So it's called multi-point statistics, it's an interesting concept. Like if you have geological patterns, let's say you have an image of fluvial fan, then you can learn that So you use like some geostatistical algorithm to learn. It's like a kriging, so it's like a correlation structures. But then you can use other soft data and hard data to update your posterior probability. So such that you can update your uncertainty model. So at the end, you can capture like rel data, geophysical data, and also if you have known geological patterns, then you can actually kind of capture that. So the theory is actually cool, but the reality is actually not that cool. So I'm facing that reality and having fun. So that's it. That was what I was doing. So to do that, I was playing with Thibault's code because most of the well data in a lithologic form, so which is different from physical property that we're inverting for. So Thibault's approach was actually perfect to encapsulate lithologic information in a different sort of dimension. So yeah, I'm really looking forward to use Thibault's approach and also further develop like how to sample from from that final inversion result. Anyway, so that's what I was working on. Nothing really specific to SimPEG, but still, I'm mostly using it.
Cool. Thibault, how's the thesis going?
Well, it's in the hand of the committee at the moment, so.
Oh, yeah.
So I didn't quite make the deadline for sending to for the external, but yeah, like so now it's in the committee and people are busy, so it's gonna take a couple of weeks. But after that, we probably send to the external by early July or something like that. So that's mostly out of the way. It's a Google file, so I did make some small edits after that just by rereading through. The case study TKC paper joint inversion of potential field data is definitely accepted too since last week, so that needs to be. So I will send the production file by today, and we still have one more paper with Lindsay and Doug to finish, but it's very close too. So yeah, it's wrapping up finally.
Yeah, nice, cool. Okay, John, do you?
So I will be back for more teamwork soon.
Okay, good.
Yeah. Nice.
John, what have you been up to?
Actually, not too much. Yeah, I just kind of been around trying to or updating everything our SimPEG related that we use for processing and inversion to the new simulation class. That was kind of fun. Other than that, oh yeah, and I worked out the tipper. My tipper data was coming in incorrectly for the coordinate system. Yeah, I guess I was mostly judging it by the EDI loader for the MT. I guess that was probably made quite some time ago, Goodney maybe. Yeah, it doesn't say anything. It doesn't treat the Z-axis with anything, it seems. They do a component swap, but we were kind of working it out ourselves, and it doesn't look like. It looks like when he brings it in from EDI, it's in the Y easting, X northing, and Z down, and then the Z wasn't being altered at all. So yeah, it kind of led me in a little bit of a bad direction, but now I got everything figured, and yeah, it seems to be working really good, and like lots of action going on the line search, and yeah, it's solving things pretty fast. I can get 6 iterations in about 5 hours or so. So it's kind of nice. That's for tipper though.
Okay.
Yeah.
How long was it taking before?
It was taking almost a day, or like 12 hours, I'd say. Yeah.
Okay.
Yeah. So yeah, things are moving now. It's kind of cool.
Good.
Yeah. Yeah, actually, I just ran into something too. I was trying to use the drape topography or drape locate or drape electrodes. We were just doing some benchmarking across our machines, and the first 2 machines that I updated to simulation like last week, the script ran, and then we just updated these 2 today, and I'm getting an error about points not being X by 3 in the mesh, or like a 3-dimensional. But when you look at it, it is 3. Like I have all 3 there, and it just stopped working on that. But I need to dig a little bit further before I'll bring it up, kind of thing.
We did make a few small changes before the tutorial to try to simplify that drape topo function, because it was a little hard to get through and hard to understand what it was doing. So we made a few small little change, or we redid it, re-implemented it. So it could be a small error there as well. So
Okay.
if you're having issues and you find something, or if you have something, we can reproduce it. Hopefully
Yeah,
it works.
for sure. Yeah, oh, sorry.
It worked on the small test examples we were playing with. So.
Okay. Yeah, it just happened this morning, so I need to dig in a little bit further, and I'll let you know.
Okay.
Other than that, playing with a lot of sensitivities too. Yeah, it's kind of cool that breaking the MT one up, Joe, like you said, into the 3 chunks. It kind of like makes it easily accessible, so you can see the sensitivity contribution from each frequency, each component. Yeah, it's kind of cool.
Yeah.
I don't know how applicable it is, but it's cool stuff to look at.
Oh, like just seeing it in between and like, oh, it's this much, and then.
Yeah, exactly.
Interesting.
Yeah.
So John, what is the status of the MT code? Is it like now parallelized with the frequency, or what's sort of?
I'm calculating the frequencies on the fly. Right now, I'm kind of going over receiver for the biggest chunk of parallelization. I wouldn't say that I'm done with the parallelization. I'm just kind of playing around with it still to see which way is better as we scale. Yeah, it's kind of a slow process. Sorry, doing what I can. But some of it's parallelized now. It's just maybe not the best optimized parallelized, but working with it.
Right. So each receiver has their own mesh. Is that what you're doing?
Each receiver patch has
Okay.
I guess it would be calculating over each mesh. Yeah, that's right.
Okay, cool.
But it doesn't seem to cost that much, really. But I guess I'm just using a tensor mesh. I'm not using Octree right now.
Right. Right.
There's still some volume averaging operations I'd like to get in on discretize that I've been playing around with, especially with Octree volume averaging for general structures. So I have ideas in my head about how to implement it. I just haven't had time to do it yet.
Right. But like, Joe, are you thinking about like kind of like a UBC style? Because it is like a nested mesh. So I think in that case, volume averaging is much more sort of readable, like I guess easy. But are you thinking about much more general? Let's say what Octree to tensor, or Octree to whatever mesh, and then do a volume.
I'm thinking about it in terms of like Octree to tensor or Octree to Octree, without having to go through the underlying tensor meshes.
Oh wow! Okay, that'll be. So one thing that I don't like about the UBC style is because your nested mesh is fixed. So like something like an airborne case. So if your transmitter is slightly off from, let's say, cell center, then your accuracy sort of changes. So in that case, I would rather actually move the center of the local mesh. So it's subtle, but
no, I understand.
Depending upon the accuracy, I think it's actually important. So yeah. So anyway, so it's
a good point with respect to that is that the Octree, the interpolation on it, the only one that's actually like, second order interpolation or whatever is the nodal interpretation or interpolation. Cell-centered interpolation is just nearest neighbor, because it's not trivial to come up with other forms of interpolation on the Octree mesh in general. It's kind of, there's a brute force way you can do it just by triangulating everything and interpolating on a triangulated mesh. But that also has some problems, as it can, because of the structuredness of the Octree, it can lead to a decent amount of degenerate triangles, which slows down the triangulation.
That'll be really cool to have that interpolation.
Yeah.
And Joe, I'd be happy to push with you on this in the sort of near future. This is really relevant for the paper with Dieter. where we're trying to run some CSEM simulations. And right now, like if we don't sort of volume average in the padding area, the accuracy we're getting isn't great. And so for doing sort of a code comparison, it's not really, I don't have results yet that I'm sort of, you know, happy to show, because it's decent accuracy, but it's not good enough when we're really trying to do a good job forward modeling. So if that's something you're interested in sort of doing sooner than later, I'd be happy to help.
Yeah, I'm definitely interested in doing it. So I guess what I've been working on recently is kind of typing as I talk here. Just kind of helping Lindsay get everything set up for the transform tutorial. There's a few little bugs there as far as the Anaconda installations, and looking for the PyMK or the MKL. I think it's a bug in PyMKL that I put up there, but I haven't seen any response to it at all yet. So I'm not sure if there's. I mean, I tried to ping Dave.
Yeah,
I tried to ping him through the SimPEG Slack, and he hadn't responded through there either. So I don't know if anyone's heard anything from him recently or not.
We went through and we were going to transfer PyMKL to the SimPEG organization, because I don't think Dave is actively maintaining it.
Yeah.
We can send him an email and see if we can do that this week.
Yeah. If not, like I said, I'm still intending on just writing possibly our own version of it that uses Python wrappers instead, so we can get a little bit more control over it. Yeah, instead of using the CPypes library import. So just a thought. What else? Oh, mostly just been trying to figure out where I'm going to live soon. That's about it. I've been sending people on missions. So that's about it.
Rent gone down at all around Vancouver? Or?
I mean, there's still places that can be expensive. I mean, I think in general, rent has gone down a little bit.
Nice.
It's to the point where it's like, okay, if it is a decently priced place, there'll still be a lot of competition for it.
Okay. Yeah. For sure.
So, yeah.
What does your ideal place look like? It's like a 1-bedroom house or 2-bedroom house? What's the?
Or like a 2-bedroom house.
Okay. Okay.
Just because, hoping to start a family at some point soon.
Yeah. Yeah. I like that. When I was living with Angela, I was in Kerrisdale. I actually like that area. Really, like that's where Devin is living. It's not like it's a very small town, but still have like a little like a downtown-ish, 41st Street, and it's more like a residential area. So it's very different from like a kids, where like lots of young people and a little bit hippie. But if you want more like a residential, I really like the Kerrisdale.
Okay. Oh, thank you. I don't know. Lindsay, how did you ever get a chance to do anything over the last 2 weeks?
Well, I guess, I mean, the transform tutorial was the weeks before that, and so thanks again for all of your help getting the DC code and stuff in shape. That was a big push. Yeah, that's about all that I've done, and then lots of driving. So yeah, that's about it.
Okay.
Maybe one thing, because what you said, Joe, for the Conda install and Lindsay, what I really blow my mind, I think the first time I wrote an environment.yaml was for the paper we're doing, but just the difference seeing people struggling with installing GeoSci and basically a non-issue with SimPEG was for me just like, wow, an environment.yaml it's such a big difference if you can just install it like that. It was really cool to see. I don't think there was anyone that had an issue except for the issue that then Joe fixed on the Windows machine. Really
I know why it wasn't working. I know why it wasn't working, and we fixed it with, switching the dependencies around or switching the channel priorities in the environment file.
Yeah, my feeling was like they were having some problem with the solver, like PyMS solver. That was my guess, because
what it was is PyMKL was not loading the MKL library. Even though it was installed, like it was all there, it just wasn't looking for it in the right spot. So it just happened on Windows for some reason. I'm not quite sure why, but essentially Windows has this weird way of looking for dynamic libraries. So it'll look in your path, it'll look in it'll look in the folder where the executable is being run from, and then it'll look in any subfolders there. So the executable that was being run was installed from CondaForge, and whatever that executable was being run from, it couldn't find the MKL library, and also the way that it was checking to try to run it from a Conda, like to try to see where Conda would have had it installed, was incorrect as well. There's like this little logic of, oh, if Anaconda is in this version string, well, if you downloaded it from CondaForge, then Anaconda is not in it. CondaForge is in the version string. So it didn't even try to do it.
I'm so glad to have you. I have no idea actually how we figured that out.
Yeah. So that's what was going on. So the solution was just to make it not use the Python installation from CondaForge and just use the default channel from Anaconda. Yep. Doug, what have you been up to the last week?
Well, I think my main mission from the point of view of maintaining SimPEG and the quality that's going on is to help scout out houses for you that have a big enough kitchen so that you can make the pasta that you and Liz want. I think that's the only thing I can do. Because if you're happy and if you're productive, I mean, that's really all we need.
Yeah.
That sounds very right.
Okay. I don't know. Does anyone have any other thoughts to add in?
Nothing like special, but there's an opening in geophysics for a special session for hydrogeophysics, and the due date is August 1st. So anyone has something. I thought like that the DC development for GWB could potentially go into that hydrogeophysics section. So yeah, I mean, this seems like a good motivation to actually publish that paper.
I know there's been some good work on case histories from over there too that might fit in.
Right, because they actually found a water, so that could make a really interesting story.
Yeah. Other than that, I know Dom also posted a message about SEG, the SEG post-convention workshop on Slack.
Yeah, I was wondering, I mean, I guess this is maybe more a question for Dom, because he seemed pretty not optimistic about running the tutorial, which I think is totally fair. If they want it completely pre-recorded, that's not fun. But I was wondering if we wanted to even just do our own thing in that slot and like basically run it, but not through SEG. I don't know if that's
I think we could probably do something like that. And I know of a decent amount of, streaming programs that we can have it set up for ourselves. And what did they have you using, Lindsay?
So, I mean, the setup was actually great for Transform. And so we could even just get in touch with Matt and Brendan and figure out exactly what they did, because I was on Zoom But then Brendan Hall, he was on the other side, basically, I don't know, there was wires between Zoom and YouTube. And I don't actually know what they used to like plug those wires. But it was, at least from an instructor perspective, it was really seamless. And knowing that he was on the other side, just like taking care of everything and making sure that the video was in a nice spot and that he could overlay links and things like that. That was,
it was like live edited.
Yeah.
It might have been some sort of like, I know I've used streaming software in the past before, like there's a nice one that it's called OBS that works pretty well for that kind of streaming, like live streaming. You can like set up the entire screen and what you broadcast and stuff and move things
I
around.
think you might want to ask Matt, he might be quite up for something if you say, well, we wanted to give a tutorial at the SCG, but it's kind of difficult. Can we do it through Software Underground? And it might actually be a very nice idea and a kickoff of other things happening if you start with it. Yeah.
That's a really good idea, because that could be a cool venue, and yeah, that could be really interesting.
To host it and advertise it, and I mean, yeah, generally.
That's a really good idea. And it seems like the transform thing went pretty well, so yeah, it could be definitely a very good thing. I mean, I'm not sure if SCG would be willing to do anything to advertise it, considering like I don't think they would make any money off of it. So I really seriously doubt they would do anything to help us.
I highly doubt it.
Yeah. Well, especially if we're gonna go off and do our own thing, because the way you're setting this up doesn't work for us. Yeah.
So, but I mean, obviously we have enough. I'm pretty sure we have enough contacts around that we can get the word out pretty well.
Yeah.
And then either way, I mean, is it even Swang or SCG? It's 90% seismic, right? And the EM potential community is so small that most have heard of you or know someone that knows you, and it's really a small world.
Yeah,
to get
I know I'm sure we could probably get in touch with the potential field section at SCG, like through that group, and get that sent out. I'm sure they would be more than willing to send that out and be like, hey, go do this. Because, you know, Chuck and all of them are really nice people. Okay, well, if there's no one else, I guess we can call it a good meeting. See you guys all next week.
Sounds good.
Yeah.
Bye, guys.